All right, hi again. So we're going to quickly explain the two exceptions to the setting out that we've established earlier. As you can see, in questions 7 and question 9, you're dealing with an object that's on a slope. And what that means is that the object will not have a tendency to move horizontally, as in this way or this way, which means we need to rename our vertical, quote-unquote vertical, and horizontal components so that they kind of at an angle. One of them is going up and down the slope, and we're going to call this sort of like the vector I, which is very strange because it's not horizontal. It's a new kind of horizontal, and the other component is perpendicular to that. And of course, you can just use names like along the slope or perpendicular to the slope. And the reason why we have that is because we have this concept of the normal reaction force, which acts perpendicular to the slope so that the slope is sort of pushing it up at the object so it doesn't fall through the surface. And the friction force acts on the surface in this parallel to the slope to prevent it from going down the slope and oppose its tendency to slide down. So the only thing we're actually dividing into components is actually the gravity force. Even though the gravity force normally is vertical and we don't really touch it, in this type of question we do need to divide it into two components. And to do that, we simply create its component down the slope and its component into the slope, and we work out a little triangle in this diagram by sort of working out the 60 degrees here and using trigonometry to work out its components. And by not confusing it with the other method, the main setting out, we use words like along the slope and perpendicular to the slope here to work out the components of gravity. And as you can see, I've here written down the slope rather than saying minus 49, but because of the way we defined it, we treat F as positive because it's going up, and therefore this is down the slope. You could optionally put a minus sign there if you really wanted to. Once we work this out, we're going to take all the components of forces acting along the slope. So F is positive because it's going up the slope, and the 49 is negative because it's going down the slope, and therefore they should balance out because the particle is held in place thanks to the friction and not accelerating down the slope, which is why the sum of the forces along the slope equals 0, allowing you to make F the subject and say it's 49.